name is Harisur, working as assistant professor in NIT Engineering College. Today we are going to start with the new subject. The name of the subject is Theory of Computation. In the subject we will start with the first module, that will be our first unit. The name of that first module is Introduction to the Finite Automata and Compiler. In the next slide we are going to see about what will be the syllabus of the first module. The syllabus of the first module consists of three sub-types. First one is the introduction. In the introduction, we study for what will the role of automata and the formal languages. Then we will study what is alphabet, what is string, what is grammar, what is language, what will be the Chomsky hierarchy of languages. Then we will study about introduction to the finite state machines. In the finite state machines, we will study for DFA, NFA, and what will be the NFA with the epsilon transition. Then equivalence of NFA and DFA. In the last, we will study for introduction to the compiler. In that, we will study for what is translators, what is language processing. Go. Translators, languages, processing system, phases, and the passes of compilations. Then in the last we will study for what is the use cases, what is the role of finite automata in NLP and in speech recognition. That will be our whole module that we are going to study in the next. Let's start with the introduction to the automata. Generally, what we say is the plural of automation is automata. That is the general term that we discuss about. Automation is the system that performs some functions without human intervention. We already know that what is automation. Automation is where we don't need the human intervention. We only give the input. According to that input, we get the output. That is known as the automation. And the plural of automation is known as the automata. Then automation theory is the study of abstract computational machines. Abstract computational machines are those where we don't need the physical devices. We only make some models. That is known as the abstract machine. And the computation problem that can be solved using these machines. That is called the automation. Abstract machines are simplified mathematical models of real automation. As we already discussed few lines before, that what is abstract machine? Abstract machine is simply a mathematical models of a real computation where we don't need the physical devices to put in. We just need to create some models so that according to that models we can create the physical. With the help of physical devices, we can create a particular solution. That is known as the abstract machine. Automation consists of some states and transitions. What will be the state? State is represented by circles and transitions will be represented by the arrows. We will study this further when we read, we'll delve more depth into this particular topics. We will study about what will be the states and what will be the transition. For now, we can understand that what will be the state. State will be those that will be represented by circles, and the transition will be those that will be represented by arrows. Now, what is the automation? Is a kind of machine which takes some string as input, and this input goes through the finite number of states and may enter into the final states. That will be known as the automation. I can give you the example with that is, suppose with the circle we are representing a state. We are starting at the Q0 state, and with the input A, we are moving to the Q1 state, and we will call this Q1 state as a final state. That is what is written in this particular line. Okay, now this topic would be why we need an abstract model. Why we generally need an abstract model? Like we can't directly work on the physical entities. We have to, before dealing with the physical entities, we have to develop our models on some things. So okay, what is an abstract model? If we discuss why we need an abstract model, so as we were discussing that we can't start directly with the physical entities, we have to draw some models so that with that help of models we can arrange those physical entities to get a solution. Let's take an example. Suppose we have to work on to glow a bulb. So how we glow a bulb? We can't directly start with the battery. We can't directly attach the terminals with the battery and to the bulb. For that we have to create some model. Suppose I am representing a battery with the plus minus, like we used to study in the physics in the plus 1 or plus 2. In that we have to attach some terminals and we have to make the bulbs like that. If my terminals are got connected, the bulbs got glow. That is, this is known as the abstract model. With the help of this abstract model, I can deal with the physical entities. Suppose in this case, I have taken a battery and I have connected the battery with the bulb. My input will be the switch. When the switch get on, the bulb would be glow. So in that case, my input work as a switch. What will be the output? Output, it means what will be my final result? My final result is I have to glow this bulb. So what will be the action? Action would be I have to flip the switch. Flipping the switch means either I have to make it on or either I have to make it off. In that case, that is the flip the switch. State. What will be the states? In that case, I have the two states. Either the bulb will glow, that is on or off. These will be our two states. That's all. According to this abstract model, if I have to create the transition diagram, then how I will create? Suppose I am setting at the Q0 state. Q0 state, it means I am taking it as a final state. In that case, my switch is off. It means I need to give some input. What will be the input? Input is a switch. So in that case, I am giving my input as switch. Suppose this is my off state. Q0 is my off state, and then with the planned switch, I am moving to the Q1 state, that will be my on state, and my final output. What is the output? I need the light bulb. My bulb will glow when I put the input as switch, and it will be my final state. This is how I can represent an abstract machine to a transition diagram. This is known as the transition diagram. In the further unit, we will learn about how you can create some transition diagrams. Let's take a second example. Earlier in that example, we have taken the first one switch only. In this particular example, we are going to deal with the two switches. So in the two switches, the bulb will glow when both the switches are at the on position. If one of the switch is at the off state, then we are not able to glow the bulb. In this particular, to get the solution of this particular problem, we have to make our switches, we have to connect both the switches with the bulb. If according to this diagram, we have to create the transition diagram, how it will be? Suppose we are standing at the off state. We are standing at the off state. If I am connected the first state, if I am connecting the first switch, then with the first switch, I will be at the off state only. To move to the on state or to make this bulb glow, what I have to do? I have to connect the second switch also. So again, if I repeat, I am standing at the off state. I am connecting the first switch. First switch means I am connecting this first switch, and with that switch connecting, I am moving to the second state. That will also be my off state only. And with the second switch connection, I will move at the on state. That's why this is we have written the on state. Again, if with the on state I have disconnected the first switch, then I will move to the off state, and at the off state and I have disconnected the second switch again, then I will move at my initial state. That is what it mentioned in the transition diagram. If we read what is written in the slide, the input will be our switches. That will be the first switch. This will be our input. Second, this is the second input. Then what will be the action? Action will be to flipping the switch 1 and to flip the switch 2. That will be our action. Then bulb is on if